This is the screencast for section 5.1, example 5. We're going to simplify trigonometric expressions by combining fractions and using the identities that we have learned in examples 1, 2, 3, and 4 so far. Simplifying this expression here. Well, first of all, we don't have a common denominator, and wow, that can get really messy if I just give this guy a cosine and give this guy a 1 minus sine of x. But I notice something here. I notice 1 minus sine of x and cosine of x sounds familiar to me. I know I have a Pythagorean identity that says cosine squared of x plus sine squared of x equals 1. And I think I have the ability to help myself out with that identity. So I'm going to try and make this guy over here a difference of squares. So I'm going to write out the original fraction, cosine of x over 1 minus sine of x. And I'm going to multiply both the numerator and denominator by 1 plus sine of x over 1 plus sine of x. Now that'll be minus, again, the original fraction, sine of x over cosine of x, but I'm going to multiply this guy by another cosine of x. So the numerator and denominator both get multiplied by cosine of x. Now up here, I'm not going to mess with multiplying that out just yet. I'm going to say cosine of x times 1 plus sine of x. Now all over, now this is a difference of squares, so I get 1 squared minus sine squared of x, minus, and now this will be sine of x, cosine of x, all over cosine squared of x. From a manipulation of that Pythagorean identity, sine squared of x plus cosine squared of x equals 1. If I subtract sine squared of x from both sides, I get cosine squared of x equals 1 minus sine squared of x. So now the question is, do you put cosine squared of x in for this expression or 1 minus sine squared of x in for this expression? Well, which one would you rather deal with? Just a cosine squared or an annoying little subtraction sign where you have two parts you have to deal with? I'm going to make both of the denominators cosine squared of x. So in the numerator I still have cosine of x times 1 plus sine of x all over. Now that expression I'm going to make cosine squared of x minus, and this expression is going to stay by itself. Don't simplify. You unsimplified here. You don't want to reduce that. You did that on purpose. Now I have a common denominator, so I can combine this whole fraction. I am going to multiply this out because I'm going to have a subtraction sign up here, so I'm eventually going to have to combine like terms anyway. Cosine of x plus cosine of x sine of x minus sine of x cosine of x all over cosine squared of x. Now these two terms, even though one is cosine of x sine of x and the other one sine of x cosine of x, they're the same. Just 2 times 3 is 6, 3 times 2 is 6. They mean the same thing. So they actually, one minus the other is 0. So I have cosine of x over cosine squared of x. When I simplify, I'll get 1 over cosine of x, which we all know is secant of x. Much simpler than the messy subtraction of fractions with not a common denominator that we got in the beginning, or that they gave us in the beginning. Let me get this out of the way. Alright, now try problem number 37. Again, we don't have a common denominator, but this one, it's not really connected by a trig identity the way this last one was. Sine squared and cosine squared, without that minus 1 in there, it's really not going to help us any. So instead, I'm going to, I could do one of two things. I could change everything to sine and cosines, but instead I'm just going to give it a common denominator and see where that goes this time. Let's see, secant of x over sine of x. That needs a cosine of x in both the numerator and denominator, minus sine of x over cosine of x. this one needs a sine of x in both the numerator and denominator. So now I have a common denominator. I am going to change secant to 1 over cosine because I am predicting that that will work out nicely, and it does. So I have my secant of x is 1 over cosine of x. Cosine of x stays the same, minus, this will be sine squared of x, all over my common denominator of, it doesn't matter, sine of x, cosine of x, or the other way around. Now 1 over cosine of x times cosine of x is 1. So in the numerator I have 1 minus sine squared of x. Then the denominator, I'm going to keep that the same. 1 minus sine squared of x, we've already demonstrated, is cosine squared of x. So one of those cosines is going to cancel out, and I have cosine of x over sine of x, which is cotangent of x.